Welcome to the screencast that is entitled An Introduction to OpenFOAM. My name is Stefan Radl and I'm from Graz University of Technology, and I have prepared this screencast for you to give you basic information about OpenFOAM, how to use it, how to modify it essentially. Before we start, let me first welcome you and give you a short outline. So we're going to start with a short introduction to this introduction of OpenFOAM. So I will show you briefly what is the material provided in this screencast lecture series. Then we will look at some preparation steps for running OpenFOAM, and I will discuss this with a focus on the operating system that we are using. This is OpenSUSE Lib 42.3, and then I'll finally give you some references that you can consult if you are interested in further reading. Then we'll start with OpenFOAM itself. In session A, I will show you what OpenFOAM is, what it is good for. So in order to do that, it's best to explain the history and the philosophy that is behind OpenFOAM, so that the creators of OpenFOAM had in their mind when they were programming OpenFOAM. And in session A we'll also go through the basics and the structure of OpenFOAM, so where the cases are located, how the applications look like, and the source code. So as you might know, OpenFOAM is encoded in C++, so that's an object-oriented programming language, and I will show you how this looks like. In session B you will use OpenFOAM for a specific purpose. We will go in detail through one of the tutorials, and you will see how you can use it. And in session C I will try to help you understanding how OpenFOAM works and how you can modify OpenFOAM programs for your own research. Good. Let us now come to the expected learning outcome of what you should learn in the screencasts here. So in session A and B, we're gonna discuss the usage of solvers and utilities. So we're gonna start with a simple mesh generation, so the generation of the geometry, the region where we want to solve our transport equations in. And for this we will first discuss the tool block mesh. Then we will look into how to define initial and boundary conditions. So very important for solving the transport equations, of course. Then we'll look into how to configure and monitor a solver. So solvers are used for solving the transport equations on the computational domain. And we will also look into post-processing, like probing data. Probing data at a specific point means that we extract time series information at a specific location. And of course averaging is another important procedure, post-processing procedure, and averaging here refers to time averaging. Another important post-processing thing is sampling. For example, sampling across a line to prepare data for a XY plot, for example. In session C, we will focus on the modification of solvers and more advanced topics. First of all, C++ experience. So you might know that OpenFOAM is encoded in the C++ programming language, and hence it is important to discuss some basics of this. Understanding the OpenFOAM structure is very important. You will see that this mainly consists of libraries. So the libraries provide very basic functionality, and this functionality is then harnessed in solvers that then are designed to solve a specific problem. In this session C, we will also look at numerical schemes, how to choose them. Then we will do a programming example implementing a scalar transport solver in OpenFOAM. And finally, we'll use this snappy hex mesh tool. You see it is also a meshing tool, but focuses on much more complex geometries and more advanced topics. Good. Let us now continue with this introduction session of this first session of my screencast series. So let me briefly explain you which material we provide. So you already see that we are talking about screencasts, so you see me talking to the slides and maneuvering around with the mouse. This should motivate you to hands-on work, so to work with OpenFOAM, which is very important, since only due to practice you can really learn how to use it. The screencasts are designed for blended learning, so essentially it means that we combine these screencasts, so e-learning tools with face-to-face training. So it's very difficult for you to learn based on these screencasts, so it's important also to have face-to-face trainings. So I also encourage you to come to trainings at TU Graz or other trainings that are given by professionals that teach you how to use this kind of software. What is important, don't expect completeness from these screencasts. There are we will see that there are very complete tutorials and PDF sets available on the net. These screencasts are not intended to be very complete. They just should give you one part of this blended learning concept. You will also see that we will use OpenSUSE Leap 42.3. This is because we have chosen OpenSUSE as our operating system here at the Institute. So you're going to see details related to this. Of course, other Linux flavors are not much different, and you can also transfer this knowledge to these distributions. Another important thing is, what I provide you here is addressing the needs of a typical researcher from the field of engineering that mainly uses and modifies OpenFOAM. So I will show you next. This is not intended to train you the basics of C++ and advanced OpenFOAM programming skills. This would be definitely out of scope of this screencast series. This is really focusing on a typical researcher that needs to use and modify OpenFOAM. And you will also see that we have some focus on applications with particles. This is simply because our institute is the Institute of Process and Particle Engineering, and don't be surprised that we're talking most of the time about particles or gas particle flows. So what is not provided in this screencast series, it's not heavy C++ programming, and we will not talk about templates. Templates are very extensively used in the OpenFOAM source code. Can be very complex to understand. We will not discuss this. I will also not talk about the mathematical models and closures. This is certainly a topic of its own. And what I will also not talk about too much are the numerics and the math behind the scenes. This is some very specific information that is also relevant for other CFD software packages, so it's simply not covered by this screencast series. So now we can come to the preparation steps that we need to take before getting involved with OpenFOAM. Certainly, first what we need to do is we need a computer system, and when you work with OpenFOAM, it's very favorable to have a Linux computer system. So OpenFOAM is designed for Linux, and there are some ports to Windows, but it's definitely just a port, so be careful. So what we use at our institute is we have a lot of Windows machines and Linux servers, so we simply use a tool like PuTTY here. This is the PuTTY tool, and then we log on to our Linux workstations, for example using this PuTTY tool that is essentially an SSH tool, and then we can navigate around this Linux system and do our calculations on these servers, and then we copy the solution to our Windows machines, and then we do the post-processing. Or of course, what is also very often done is that we have a Linux workstation just at our desk, and we switch over to this Linux workstation whenever we feel we need to do our simulations. There are specific installations instructions for OpenSUSE Leap that I have put together. There is an appendix that you will also find in the material provided, and this explains you in great detail how to install and compile OpenFOAM on OpenSUSE Leap 42.3. All note for Windows users, there are ports, as I mentioned before. So if you go to this page, you find a a port to Windows 10. What is also a very good port is KLOS. So KLOS is a derivative of OpenFOAM that is very easy to install on Windows systems. And another provider is CFD Direct, the company of Henry Weller, and they use so-called Docker containers that you can run also on Windows computers. So there are ports available, but it's not the native thing of OpenFOAM to be available on Windows. So this installation is covered by separate screencasts, so we don't need to go into details here. Before we start, we have to ensure that the OpenFOAM variables are loaded. Yeah. So it's important to check that your OpenFOAM installation is sourced in your bash or C file. So we are working on this OpenSUSE system, and if I now check my bash or C file, which is in the home directory, you will see that I do this here, source opt OpenFOAM x etc bash or C. This is also in the installation instructions of OpenFOAM. So if you source this bash or C file, we have the OpenFOAM variable environment set up. Everything is done for us, so that's great. So that's virtually the only thing we have to do to load the OpenFOAM environment. In order to verify that this has worked, it is instructive to simply type foam, yeah, and then press the tabulator, and then you will see the different foam functionalities, foam applications you can start. And if you see this is a good sign that everything is fine with your OpenFOAM installation and your OpenFOAM environment is set up. What is also useful is that you have a lot of aliases. So if you check out this file here, yeah, so the WM project dir is the installation directory of OpenFOAM. So in our case this is opt, OpenFOAM 5, yeah, etc config.sh. If you look into this, if we look into this directory, we find this file aliases, and if you now look at this, we find all the aliases that are provided by OpenFOAM. For example, source, lib, app, sol, util, tut, run. These are the core aliases that are provided by OpenFOAM and that help us to navigate more quickly through the computer system. For example, if we would like to navigate to the OpenFOAM applications, this one here, we simply type app, yeah, and we're in the OpenFOAM application directory. If we would like to navigate to the tutorials, yeah, the tutorials are located here, we simply type tut and we will end up in the tutorials directory of OpenFOAM. Before we start, it's also good to copy some tutorial cases. For example, the cavity case, we will talk about this in great detail. At this point, you can simply type tut and you will end up in a directory with all the OpenFOAM tutorials. We will look at this in closer detail in just a minute. And next, finally, step number 5. I would also like you to hint you to other web tutorials. You might be happier with other courses or just a brief glimpse of OpenFOAM. I have to put together an appendix. Yeah, we will talk about this in a second. That lists other recommended tutorials, guidelines, or screencasts that help you to work with OpenFOAM. Finally, here are some references. So these are the must-haves. Must look at the company CFD Direct has a very comprehensive user guide, very useful, and also the official OpenFOAM wiki, wiki.openfoam.com is a very nice page where you find a lot of tutorials, full week courses that you can go through, so very comprehensive. You find also there links to YouTube videos. Everything is very well organized. Another important reference is PowerView. So PowerView, we will use it, is the main visualization tool that's connected to OpenFOAM, and there's an excellent tutorial provided by CFD Direct. You find it here in this web address. It is a very short but still comprehensive introduction to PowerView. More documentation and tutorials. You will see there's a lot of tutorials that you can look at, so it's important to make a good choice. We will look at the appendix in the detail, so there's this other training and repositories MD file where you find all the links, and certainly for PowerView you need a specific training because it's simply a huge package and you can do a lot of it, and most of the users spend most of the time working on PowerView and not really working with OpenFOAM because simply they start the simulation and then they do all the post-processing work. So it is also important to know very well PowerView. If you have certain needs that you think others or problems that you have found in the code, it's also good to go to the forum. You see here the OpenFOAM forum. And last but not least, if you're really interested in the source code, then either look into the source code directly or navigate to this page here. This is a comprehensive source code documentation of the OpenFOAM classes. So this is it for this introduction to my screencasts. I hope you like it and you continue with session A.